Welcome to The Explainer, everyone. Today, we're diving deep into the massive, silent architecture that literally runs the modern internet. We're demystifying database management systems. We're going to move past the basics to understand exactly how apps handle unimaginable scale and complexity every single second of the day. Let's get right into it.
Just think about the sheer volume of data moving globally right now. When you open up an app like Instagram, YouTube, or your mobile banking app, how does it instantly retrieve and load your exact profile? We're talking about architectures managing hundreds of millions of concurrent users, billions of high-definition files, and endless streams of microtransactions. Pulling all that data instantly without dropping a single crucial detail? That is an absolute monumental engineering feat.
So here's our roadmap for today. We'll start with the data problem. Compare data versus database. Meet the DBMS itself, unpack its core advantages, and finally look at DBMS in action.
All right, part one, the data problem, or as I like to call it, managing the chaos.
Imagine an environment managing hundreds of thousands of individual user records. Actually, picture a massive university network. If those records are just sitting there as unindexed, unstructured flat files, processing even a single query becomes a total latency nightmare. Without a dedicated system to index and parse all that info, trying to do a simple lookup requires scanning literally every single document one by one. It's wildly inefficient, highly prone to data corruption, and just a massive headache for read/write conflicts. At scale, unstructured information isn't just slow, it brings operations to a screeching halt.
Moving on to Section 2, Data versus Database. Finding order.
People often mix these two terms up, but the distinction is absolutely critical. Data, in its rawest form, is really just isolated facts. A name, an age, a string of numbers. Standing completely alone, a random phone number doesn't have any context or utility. A database, on the other hand, steps in to solve that structure problem. It takes those isolated data points and maps them into a highly organized, related collection. It enforces a logical architecture. This means raw information is actively linked, indexed, and structurally optimized so your complex queries can execute in milliseconds rather than taking actual minutes.
Which brings us to Section 3, Meet the DBMS, the hero of our story.
So while the database represents the structured architecture itself, the database management system, or DBMS, is the active intelligent software layer sitting right on top of it. Think of it as the engine. It's the software that actually helps users and external applications create, store, manage, and retrieve all that data efficiently. Instead of an app trying to messily manipulate files directly on a server, it talks to the DBMS. The DBMS handles all the really heavy lifting, the complex logic of memory management, concurrent access, query optimization. Basically, it acts as the ultimate middleman between raw storage and the end-user application.
Now, the modern tech stack relies on a few heavy hitters to make this happen. If you're building a flexible open-source web app, you might lean heavily on highly optimized relational engines, think MySQL or PostgreSQL. Now, if you're running massive-scale, complex enterprise architectures, the proprietary giants like Oracle or Microsoft SQL Server usually handle that load. And hey, for applications that need really rapid, unstructured document storage, non-relational platforms like MongoDB lead the pack. Every single one of these names represents a distinct philosophy on how to move data at maximum velocity.
All right, Section 4, Core Advantages of DBMS. Unpacking the why.
To really grasp why these systems are completely non-negotiable, let's track a single transaction together, like transferring funds on your banking app. The exact second you hit transfer, the DBMS ensures easy data access by instantly locating your specific account ledger out of millions. It guarantees data consistency, meaning the moment your balance drops on your phone, a teller in a physical branch sees that exact same updated number. It enforces reduced redundancy, so transaction logs aren't needlessly duplicated, which saves massive compute and storage costs. On top of all that, data security protocols are actively blocking unauthorized queries, and continuous backup and recovery features mean that even if the server suddenly loses power mid-transfer, your money is perfectly safe and accounted for. It's brilliant.
Moving into Section 5, DBMS in action, real-world applications.
The versatility required to handle this tech at a global scale is just remarkable. Consider the absolute, literal life-or-death precision needed in a hospital's DBMS. It has to instantly map patient allergies, medication histories, and real-time vitals without a single margin for error. Zero. Now contrast that with the pure brute force concurrency needed by a massive e-commerce platform on Black Friday. You've got millions of users adding items to carts, processing payments, updating global inventory, all at the exact same time. Both of these completely different scenarios rely entirely on a DBMS to keep their digital infrastructure from just collapsing under the weight of its own traffic.
Bringing this right back to you on a personal level, every single interaction you have on platforms like YouTube, Facebook, or your banking portal, it's all heavily orchestrated by these systems. Your encrypted passwords, the highly specific algorithms serving up your video recommendations, every post you have ever liked, and every financial transaction you've made. Without a DBMS dynamically parsing and protecting this chaotic ocean of metrics, the modern personalized web would be completely fundamentally impossible to run.
So here is a thought for you. The next time you unlock your phone and a complex, customized interface loads perfectly in under a second, I want you to ask yourself, how exactly is the data in my favorite app structured? Is it relying on a massive, highly structured relational grid, or maybe it's utilizing a flexible, document-based architecture? There is a surprisingly deep, fascinating world of database architectures out there, and you guessed it, that is exactly what we will be unpacking next time. Until then, keep exploring, and thanks so much for joining